Alright, unit 1.2, part 1, which is line segments, where we learn about the segment addition postulate. Alright, line segments. What is a line segment? A line segment is just a piece of a line. A line extends in two directions forever, so you can't measure it, right? If you want to measure it, you have to cut it into pieces. So it's just a piece of a line. And because it's just a piece of a line, it's measurable. You can find the distance, and it has two endpoints. Right? So it's going to look something like this. When you find the distance of this segment, you could write it two different ways. You could say length of AB, or you can just put AB with a segment on top. It doesn't have arrows. It's not a line. It's just a segment. Right? You can write it either way. The line addition postulate, the segment addition postulate, segment, which is just a piece of a line, addition, which is just combining, adding together, postulate, which is just another word for a rule that always works. Postulate is a proven theorem. It's just a rule that always works. The rule is, if points A, B, and C are collinear on the same line, and B is between A and C, then AB, the segment, plus BC, the segment, equals the total of AC segment. Right? So it's going to look something like this. A, B, C. They are collinear on the same line, and B is in the middle of A and C. Right? Then the rule is that this piece plus this piece will equal the whole thing. Right? So let me show you what that means. So if you have if the first piece is 9 feet, inches, centimeters, doesn't matter. If AB is equal to 9, right, this piece, the distance is 9, and this piece, this segment, is 18, so the segment BC is 18, and they ask you what is the distance from A to C. A to C is your question mark. It's this piece plus this piece equals the total, right? So it's 9 plus 18 equals your AC, your total. But instead of a question mark, let's put an X. You can't use a question mark in an equation. Let's use X. That's why we use X, because it's an unknown. It's our question mark. So in this case, 9 plus 18 would be 27. So the total distance from A to C is 27. This is what you need to remember for segment addition postulate. Every problem they give you can be put into this equation and solved. You have to remember this piece plus this piece equals the whole thing. Okay, let me show you. Alright, so suppose you have do ABC again. They're not always going to be ABC, but as long as it's 3 in a row and the middle one is in the middle, right? A, B, C, it's alphabetical, right? Let's say this time AB is 12, BC is 15. What is AC? You should be able to pause and solve it. Okay, you're unpaused. AB is 12, BC is 15. Equation says we add them together to get the total. So 12 plus 15 equals X, our unknown. Start using the X because when they get more complicated, it's going to be really important. 27. Somehow they ended up being 27. That's funny. So the distance from here to here, all the way here, is 27. We just combined them. We added them together. That's why it's an addition rule. Right? Let's make it more complicated. I'm going to erase this because you can pause it. But also because you can just draw another line. I only have so much flat surface, right? Okay. So let's say, let's add a variable. Alright, let's say x plus 3. A to B is x plus 3. And B to C is 2x minus 3. And let's say the total distance is 15. The same exact equation. This plus this equals 15. Now you know why I showed you how to combine like terms. They have the same variable, you can combine them. 2x and 1x. I put the 1 because there's an invisible 1 in front of any naked variable. If it's naked, there's an invisible 1. 2x and 1x is 3x. You can combine the constants. 3 minus 3 is 0, so they cancel each other out. Bring down your equals 15. 3 times x, opposite of multiplication is division. What you do to one side, you have to do to the other. You have to keep it fair, balanced, equal, right? So you're left with x equals 5. So it doesn't matter what information they give you, it goes into the same equation. All right, let's do another one. When you think you've got it, pause it before I answer it and see if you get it right. Let's use different letters this time, just so that you know it can be different letters. E, F, G. Once your brain connects it and makes sense, you can visualize the line and create the equation. But until you're comfortable with it, always draw the line because you can use it as a visual, like a visual aid, right? So, what information are they going to give us? They're going to tell us that e to f is 8x minus 17. So this piece is 8x minus 17. They're going to tell us that f to g is 5x minus 3. So this piece is 5x minus 3. And they're going to tell us the total, EG, is 71. That means the total distance is 71. All you have to do is put it into the equation. This piece, 8x minus 17, plus this piece, 5x minus 3, equals the total, 71. Again, combine your like terms. 8x plus 5x is 13x. Negative 17 plus a negative 3 is the same as negative 17 plus a negative 3. Think about it like money, debt. If something costs $17, that's a debt, costs $17, and something costs $3, how much does it cost in total? It costs $20 in total. Right? Think about it like debt. Now it's just a basic two-step equation. You can do this. I showed you how. If it's a negative 20 constant, we're going to use the opposite, the inverse. We're going to add 20 to both sides. We're canceling that negative 20. Bam. Cancel. We're left with 13x equals 71 plus 20 is 91. Trying to isolate the x. This is 13 times x. The opposite is to divide. We're going to divide by 13 to cancel it. 91 divided by 13 is 7. Right? So again, combine your like terms, cancel your constant, cancel your coefficient, box your x. Alright? You do it this time. Do 4x plus 3 and plus 2x plus 13, and the total A to C is going to be 46. You do it. Set it up. Pause it. Alright, hopefully you set it up like this. 4x plus 3 plus 2x plus 13 equals 46. Hopefully this is how you set up your equation. Now pause it. Combine your like terms. Alright, 4x and 2x is 6x. 3 and 13 is 16. Bring down your equals 46. Now you have a two-step equation. Pause it. Keep solving. Alright? It's a positive 16. Your constant is a positive 16. So we're going to use negative 16 to cancel it. Now we have 6x equals 30. That's 46 minus 16 is 30. Now you have 6 times x. To cancel the coefficient, we're going to divide by the coefficient. X equals 5. Alright, so hopefully that's what you got. Side notes. This is asking for the value of x. Find the value of x. If that's all it asks for, then you're done. But what if it asks for AB? If it asks for the distance between AB, then you have to go a step further. Now that we know what x is, we can replace the x. Substitution property says if you know the value of x, you can replace the x with that value. So we're going to rewrite this expression, but instead of x, we're going to put times 5. Put it in parentheses to remind you to multiply. So 4 times 5 plus 3. This is 20 plus 3. So the distance between A and B is 23. Always go back to the original question and read it again. Make sure you actually answer the question. So if it says find the value of x, you're done. But if it says find the distance between AB, then you have to finish it, or it's wrong. Alright, let's complicate it a little bit. So far we've done combine like terms, solve the two-step equation. We've done combine like terms, solve the two-step equation. What if they complicate it? Alright, so what if the problem is 27 plus 3x minus 1 equals 5x plus 2. You should notice a difference. This one had an expression and a constant. This one has a constant and an expression. Don't panic. It's the exact same equation. Right? So, we're going to do this plus this is equal to this, to the total. EG is the total. It's the total length. Right? So 5x plus 2. You still start by combining your like terms. Constant, constant. 27 minus 1 is 26. So bring down your 3x. You have a positive 26. Don't forget your plus sign. There's an invisible plus sign right there. Make sure it comes down. Otherwise you'll be very confused. Equals 5x plus 2. Now you'll notice that the variables are on different sides of the equation. They're on different sides of the equal sign. You can't just combine because they're on different sides of the equal sign. You have to cancel this variable term. You have to cancel the whole thing and then bring it over here. So if it's currently a positive 5x, to cancel it we would subtract 5x. But what you do to this side, you have to do to this side. I'm going to line up like terms. I'm putting it under the 3x because they both have the variable x. These will cancel. 3x minus 5x is a negative 2x. We're also going to move, well, I'm not going to do it yet. I don't want to get ahead of myself. I'm sorry, I was moving too fast. Alright, now we have our basic two-step equation. We moved our variable term. They're on the same side. We're good to go. Alright, we have a positive 26. We're going to take away 26. We're left with negative 2x equals negative 24. If you owe $26, it's dead. It's a negative, it's dead. If you owe $26 and you pay $2, you still owe $24. Dead. Right? We have negative 2 times x, so we're going to divide by negative 2. Here's the deal. A negative times a negative is a positive. A negative divided by a negative is also a positive. The same rule applies. And 24 divided by 2, anytime you divide by 2, it's just asking for half. So what's half of 24? 12. So if all they said was find the value of x, then you're done. Value of x is 12. Box it up and you're done. But if they asked for something else, suppose they asked for the distance between E and G. If they ask for E and G, then you have to plug it in. You have to substitute the x for the value and solve. So instead of 5x plus 2, we're going to put 5 times 12 plus 2. 5 times 12 is 60 plus 2, which is 62. So the distance between E and G is 62. If it asks for this, you have to make that extra step. If it asks for the value of x, you're done here. Right? If you were noticing and paying attention, every equation was set up exactly the same. It doesn't matter what information they gave us. It doesn't matter what information they gave us. We set it up all the same. What mattered was you combine your like terms, you make sure the variables were on the same side, you solved your two-step equation by canceling your constant, and then you canceled your coefficient, and you found your x. And then if they asked for something else, you use the x to get to something else. Right? That's what matters. Alright, so this is just part 1 of 1.2. Hopefully this was helpful. Take good notes. You're welcome to, when you're done taking your notes, you can come in during makeup day and do your practice sheet. And when you're done your practice sheet, you can get your mastery check. That's how you make up missed assignments. Good luck.